Hello everyone, this is Rashel Garg from VITMAS and today I'll be explaining the topic volume and surfaces. So first of all we need two files to work with, which is ViewSolid and ViewSolid1. So this is ViewSolid and this is ViewSolid1. So we download it from here and then we just upload it to our Matlab drive. So coming to the first question, first of all, to find volume under the surfaces, we basically use double integral. So there's a particular syntax to use for double integral, which I will show you. The very basic way to start a program is using clear all, which is like you clear all the garbage value, which of the old program and everything, and we then declare our variables. Say here it is x, y, and z. Then we use our syntax for double integral, which is this. And in this, so two integrals are there. We use intent to denote that there is two integrals. This is our z, which is x plus y by 4. This is our first variable with which respect to which we integrate. So x, and the limit is x by 2 to x. Then we integrate with y and the limit is 1 to 2. So this will be our answer, 49 by 96. So right now, to visualize that which volume are we finding exactly, this is where we use ViewSolid or ViewSolid1. So the difference is basically we use ViewSolid when the limits of y is not a constant. So here, as you can see, the value of x is a constant here, the limits, but the limits are actually given as a function of y, as a function of x. So this is where we use ViewSolid. So when y is not a constant, we use ViewSolid. When x is not a constant, we use ViewSolid1. So for ViewSolid, this is the syntax. So in this, basically, as you can see that ViewSolid is first used, then this is the common syntax in as well. Then we use the function, then we basically kind of copy the whole thing just without this bracket, and and then we can do it. So this is our z, this is our y, this is the lower limit and upper limit of y, this is x, and the lower limit and upper limit of x. So we can see the figure graphically now, and so this blue lines is the one which is the volume which we were trying to find, which the answer was 49 by 96. So this is how we find volume between two surfaces. We basically find it with respect to different planes, and then we can use double integration, and then we can use ViewSolid. The syntax is this, and so coming to the next question. So this is our next question. We have to evaluate the integral by changing the order of integration. So for this also it is very easy. We first use CLC, then we declare the variables, and then we write our double integration. So this is our double integration format. This is 4x plus 2, we use the limits, and then x 0 to 2. So for this we get the answer 8. So even after changing the limits of integration, we should still get the answer as 8 because the volume won't change. Maybe just the format of writing this whole thing is changed, but the answer should still remain the same. So we again use ViewSolid because again here y is not a constant, so we use view solid. When x is not a constant, we use view solid 1. So this is our so this is our view solid 1, sorry, view solid, and this is the syntax, this is the z, this is y, the limits, and then x limits. So this will be our figure. Now here, over here, the blue line's the one between the red and the blue curve, where between these two is the volume which we were finding, which is to which the answer is 8. So now after changing the limits, so in changing the limits, we basically first here y is equal to x square and then 2x, right? So now we will find x in terms of y. So here y is equal to x square. So which will mean that x is equal to square root of y. And over here also it is y is equal to 2x. So x will be y by 2. So the same thing goes here. X is equal to 0 and 2. So we again use this formula. We put x is equal to 0. So y is equal to 0 square, which is 0. Then x is equal to 2. So we use 2 in this. So 2 into 2, 4. So this will be square root of 5 to x by 2, and this will be 0 to 4. So for that, so as you can see here that this is the integration after changing the limits. This is the integration we get. Now as I said that we should still get the same answer, so we should still get 8, and thus we get the answer as 8. Now this was our second question. Now moving on to the third one. So this is our next question. This is in which this is not very complicated. So here instead of the limits, we have been given an double integration with, but r is in the form of a set. So but here again we are given the limits of x and y, so it is very easy for us to use it. So yeah, this is first of all we start with clear all. We declare our variables sims x, y, z. Then we do our view solid. We do our view solid and then can see our figure. So this is our figure. So there are a few things to note about this. First of all, that of course that the volume which we will find right now using double integral, it will be this, the blue line area. And second of all, the volume is actually in the negative side of z over here. So which will mean that whatever double integral answer will come, it should be negative. Although volume can never be negative, but it's just a notation to show that the function is actually in the negative. So over here we use double integral, and let's see what the answer will come. So this is the double integral. We used our function. We used y, the limits y to 1 to 2, and then x 0 to 2. The answer should be negative, and therefore. So the answer is actually minus 12. I already explained the reason behind why it should be negative. It is because the volume is actually, it is under z, like it is under z is equal to 0. So it is z is equal to 0 is actually, like this function is actually below the domain of integration. That's why it is negative. So coming to the next question. So this is our next question, in which instead of the limits we are given as in this format 1 comma 2 cross 0 comma pi. So this is also very easy. In this we basically, again we start with normal sims. We declare our variables and we first write it in this format. So basically in this it means that the first one has to be x and the second one is y. So we find the answer for that, use double integral. The answer is 0. So we should now find what is the figure like and how is the answer 0. So this is the equation for the view solid one. As you can see, um, x is not a constant here, so we use that and we get the figure now. So yeah, this is the figure that we have. It, as you can see that everything is overlapping and everything. So this the answer is of course 0 because uh, the function, it takes both positive and negative values, and there is definitely a difference of volumes. So there is some volume is above r and some volume is below it. That's why I think both of them, since they are equal in magnitude, and the final answer is 0. So which also means that the volume above r and the volume below r, both of them are equal. So V1 is equal to V2, and but they are opposite in magnitude. Sorry, they are opposite in signs. So one is positive and one is negative. So thus they cancel each other. And coming to our next question. So now we come to our next question. We again use CLC to clear our screen. The next question is, so this is our question. In this, again, R is not given to us, so we have to use, but it is given in the form of a set. So the value of x and y, the set, it is 12. So first of all, basically, of course, use CLC, clear all. We declare our variables. This is common to all the programs, as all of you can see. So first, this is our view solid function. We see the diagram. This is where we actually have our volume. So as you can see that z is negative, so the area should also come in negative. So we again use our, just to check, we use our double integration format, which is double int. So in this we have double int, and so yeah, the answer is -12. It's because negative was because z was actually negative. So the whole diagram was actually in negative z. That's why the answer is also negative. Of course, just to report, we take the modulus of the answer, which is 12. So yeah, thank you for having me and thank you for listening. And I hope you understood everything I taught. Thank you.